We'll proceed in vector summation integral calculus. Okay, vector summation and integral calculus. The discussion topic that we have taken. How to divide problem into n different parts and solve part by part. Okay, when we divide problem into n different parts, then if I solve a particular part, that part should be solved by vector. That is the concept that we are pursuing. That should be solved by vector. And then if I solve the one part, then I assemble it through sigma. Sigma I equal to 1 to n, where what is the solution for the one part? Then I would generalize that solution for all the parts. Sum it. If I sum it for n part and it is still not the exact solution, and then we make n tends to infinity. Okay, if I have summation of n part where n tends to infinity, then it can be candidate to be brought it into integral calculus. Okay, but it is not direct integration. Integral calculus is not summation of entities where n tends to infinity. Integral calculus is summation of sub-area, because integral calculus makes a area. Integral calculus calculates a area of a graph. If I say, if I say, if I say fx dx, function over x dx integration, it calculates the area that is made by fx along the dx. Dx means x-axis. D sign is given just to differentiate it from the multiplication. If I say fx x, then it looks like multiplication. Fx dx, d means it is integral calculus. People say dx part as differential part, whereas fx they call it as a kind of integrand, I believe integrand, differential, and then the limit part, integrand and differential. Integrand is the height, that is fx. Function over x, what is function over x? If this is x-axis and this is y-axis, then there is a function over x. What is function over x? Function over x is nothing but height only. At any point x, if this is x-axis and this is function over x graph, this is y-axis, this is x-axis, this is a function graph. What is function over x? Tell me at what point you want. I point at any point here. Then you draw a vertical line, it will hit this graph. This height is function over x at this point. Function over x is the y height, y point or height at any point x. Simple. Okay, fx dx means area underneath it. That is fx dx. Okay, that is equivalent to, I believe it is a common sense. If I have x-axis and if I have y-axis like this, and this is also called function over x-axis. This is function over x graph. If I say integration fx with dx from where to where? From point x1 to x2. Then x1 to x2, if I take up, then it will hit the graph at these 2 points. These 2 points. Means below this graph, below this graph 2 points, there is a line that go hit the x-axis. In between, what is the area? That is fx dx between point x1 and x2. This is the area. Now, up to anyone to divide this area into n different parts. If I divide this section into n different parts between x, x1 and x2, I chop into n different parts. Each part has a width, that is x2 minus x1 by n, and then it has a height. If I take at any point x, then height is fx. If I multiply this height with the width of one section, if I chop into n part of the one section, if I multiply, consider that is delta x, then it is fx into delta x. If I chop between x1 and x2 n times, then there are section now, section number 1, 2, ith section. If I'm talking about the ith section, this is the function over x at the beginning of the ith section. This is the width of ith section. I can say delta xi, function over x at x equal to ith section into delta xi will give this area strip. This area strip bottom is flat and top is also flat. It's not curved the way it is shown here. That is the problem. But anyway, this is the area of this strip. If I go next I plus 1 section, this is the area of the strip where vertical will be little less, like that. If I add all the area between x1 and x2 n different area, it will give more or less approximately from here to here beneath area, approximately. Why approximately? Because top side is flat, it should be curved. If top side is like this curve and then bottom side is x-axis, then if I add all the sub area, it will be exactly like fx dx x1 to x2. It is approximating. So I can say summation I equal to 1 to n function over x, x belongs to beginning of the ith section, delta xi. It is similar to integration x1 to x2 fx dx. Okay, it will be exactly same if n tends to infinity. What is infinity? God knows. If n tends to summation I equal to 1 to n tends to infinity, n tends to infinity, fx dx equal to, I'm sorry, summation I equal to 1 to n fx delta xi, x belongs to ith section, equal to n tends to infinity, equal to x1 to x2 fx dx. This is the approximate. Please watch our previous video, one day before video. There we have talked what is actually the integral calculus. Integral calculus is not formed by doing this operation. Summation I equal to 1 to n tends to infinity, function over x in the ith section, delta xi. If I sum like this, then this will become x1 to x2, x1 to x2 limit fx dx. That is not true. Reverse is true. Fx dx is a pure area. Area can be described like this. Because of this area formed like this, that is not. Generally, people describe in this fashion. Because of this fx dx limit has come, not true. Limit and fx dx has different story altogether. This is similar to this sigma. Anyway, but sigma is, but if I say whatever we are doing right now, we are dividing our problem into n different parts, solve part by part and then add it. Like I am trying to calculate area of a circle. Any shape someone can calculate. I'm trying to calculate area of a circle. If I'm trying to calculate area of a circle, I divide the circle into n part. How you divide? Just n part. N part can be anything. What can it be? Anything? Okay. N part can be like this. This is y-axis. This is x-axis. I chop x-axis into n part, and then I chop y-axis into the n part. Makes sense? Then I have small sub area. Okay, now it is divided into actually n into n part. This is divided into n into n part. Okay, now I can write as summation I equal to 1 to n. Means x-axis I denote as I. Summation j equal to 1 to n. Y-axis I denote as n, where n tends to infinity. If I take any ith jth section, area of the ith jth, if I sum, it will give this area of the circle. Okay, it may not be perfect, people will say, because at the end it is curved. It is not rectangular the way you are thinking at other places. That we will tackle. So this is also, but this is different from the integral calculus breakup. If I break integral calculus, then there is fx and delta x together, because integral calculus is summation of area strip that is required. because integral calculus is calculation of area. Summation of area strip that form the complete area, that summation is equivalent to the integral calculus. Summation I equal to 1 to n and then function over x delta xi. Whereas if I'm trying to calculate area by chopping it, or if I say if I want to chop only in n side, then I can think in other fashion. Consider this is radius, and radius is rotating polar coordinate system inside Cartesian coordinate system, hybrid mode. This is this is radius. Radius is rotating like this, and 90 degree, 180 degree, 270 degree, 360 degree. Now radius is moving. So radius is sweeping in a way that it is making a full circular area. If this area it is making, radius is constant, angle is rotating. So angle 0 to 2 pi. If I chop this angle into n different parts, then each part area I can say AI. Okay, many times I have described this. Okay, then I can say it as AI. This is the area number 1. This is area number 2. This is the radius that is moving like this, and when it moves 360 degree, it makes a complete circle. If I chop this angle into n different parts, this is the area number 1, area number 2, area number 3, area number ith area, like that. N areas are there. Summation I equal to 1 to n area of the ith section. That will give the net area. Okay, if n tends to infinity, consider n tends to infinity, then can I rewrite as limit area of the ith section dx? If area of the ith section I consider as fx, then summation I equal to 1 to n fx, can I rewrite as integration fx dx? Certainly not. That is the difference between normal sigma. Normal sigma means the summation. Summation has to be in shape of fx into delta x. Sub area, summation of sub area only constitute the integral calculus, not only summation of item. Here it is summation of item, mind it. Summation I equal to 1 to 1 area of the ith section. Here there is no delta x. Delta x is required. It has to be in an area manner, means function over x into delta x. Area of ith section can be a lump sum value. We don't want lump sum value. Lump sum value into delta x, both is required. Then only I can convert it to integral. If it is not there, then make it. If it is not there, then area of, if I draw something like this, then if this is x axis, then I, if this is, consider this is theta axis. If this is theta axis, this is 0 and this is 2 pi. I chop it into n part. This is 0 and this is 2 pi. I chop it into n part. If I chop it into n part, then one part is the width of delta theta, that is 2 pi by n delta theta. At this delta theta, ith section, consider I am going to delta theta is the width of one section. First section, second section, ith section, nth section, where each width is 2 pi by n. If this is the ith section, that is delta theta, at this, if I draw a vertical bar, then this will be area of the ith section. That is only vertical bar. If this is theta, then this is area. At this theta, what is the area? That is area of the ith section. This is the ith section. It should be whatever is the vertical bar. If I multiply with delta theta, then it will give the area of this strip. Right now I'm calling it area. Summation I equal to 1 to n area of the ith section. But that is a lump sum value. That will be just considered as a vertical bar only. It has to be in shape of function over theta, delta theta I. This is delta theta I, function over theta. Right now I can just say it is function over theta only because it's a single bar. There are n number of bars. I want bar height into delta theta. Now I'll reconvert this bar height into another height, so that another height into delta theta will become bar height. Now we have summation of the area substrip. If I rephrase this, summation I equal to 1 to n area of the ith section. If area of the ith section can be renamed as function over theta into delta theta I, where function over theta into delta theta I equal to area of the IS section. Means function over theta will be less than area of the IS section because I am multiplying with delta theta I. If I find some function which satisfy satisfy this equality, then I have summation I equal to 1 to n function over theta delta theta. Now it can be converted into integral calculus. That is the miniature science. Anyway, we will proceed now. We are in phase of calculating the area of the circle through the vector and through the different coordinate system. Now this is area, this is circle, and it falls in xy plane. This is x-axis, this is y-axis. Okay, this is x-axis, this is y-axis. This is called xy plane. This is called xy plane. There is another plane called theta r plane. If this is theta, then this is r. Theta r plane. There is a xy plane and this is theta r plane. Where are you bringing theta r plane? Not required. I have a circle in xy plane. I'll give you the equation of the circle if you want. Okay, tell me what is the equation of the circle. Equation of the circle is x square plus y minus 1 by 2 whole square equal to r square. X square plus in bracket y minus 1 by 2 whole square equal to 1 by 2 whole square. What is that? That is equation of circle. Shifted by 1 by 2 along the y-axis. Y minus 1 by 2 means it is shifted 1 by 2 along the y-axis. 1 by 2 whole square. It is radius of 1 by 2. Now calculate. Okay. So it looks like this is x-axis, this is y-axis. If there is a circle centered at the origin, then and radius is half, then equation of the circle is x square plus y square equal to 1 by 2 whole square. If I shift it half along y-axis, it will become like this, where the end of the circle is touching the origin. What is equation of the circle? Which center is 0, 1 by 2. Then the circle will be x square plus in bracket y minus 1 by 2 whole square equal to 1 by 2 whole square. What about equation of this circle, which radius is 1 by 2? It shifted 1 by 2 along x-axis. In that fashion, equation of circle is x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. What is the equation of this circle? That shifted 1 by 2 along x-axis and 1 by 2 along y-axis. X minus 1 by 2 whole square plus y minus 1 by 2 whole square equal to r square. R is the radius of the circle, or a square, or 1 by 2 whole square. 1 by 2 is the radius of the circle. Consider I have a circle like this. What is the circle? Circle equation is x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Calculate the area of the circle. Okay, simple. Okay, now we are doing something different now because it is difficult to calculate this. Now I have this is xy axis. Now I have now another axis called theta r axis. We are bringing to help for help. Okay, this is how I want to solve it. Consider this is xy axis. There is another axis I am bringing in, new axis called theta r axis. There is a relationship between xy and theta r. What is the relationship? X equal to r cos theta and y equal to r sin theta. X equal to r cos theta and y equal to r sin theta. That is the relationship. Okay, if that is the relationship, what do you mean? What I mean is, if this is the circle we are talking about, if I take all point here, what is the all point? Each point, if I take this is half, this is 1, this is minus half. If I take all the point at x comma y, then I will have accordingly r and theta. X equal to r cos theta, y equal to r sin theta, r square equal to x square plus y square. I have r as a function of x and y. I have theta at tan inverse y by x. I have theta as a function of y and x again. I have r as a function of y by x again. For every x and y, if I compute theta and r, that those will be the point that will fall on theta r plane. What are those? What is the equivalent of x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square? Someone can try. X square means r square sin square theta plus y r sine theta minus 1 by 2 whole square equal to 1 by 2 whole square. Someone can try how it will be resolved. If someone tries solving it, it will become r equal to sine theta. X square r square cos square theta plus y sine theta minus 1 by 2 whole square r square sine square theta plus 1 by 2 whole square minus minus 2 into sine theta 2r sine theta into 1 by 2, I believe so. Okay, then r square cos square theta r square sine square theta will become r square. Okay, 1 by 2 whole square and right hand side 1 by 2 whole square, that will go away. I have r square minus 1 by 2, sorry, 2 into 1 by 2 r sine theta. All will go away, minus sine r sine theta. If I take out that side, it will become r square equal to r sine theta, r equal to sine theta. Okay, actually I never tried this earlier. Anyway, so now I have a kind of, if I have a circle like this, if I have a circle like this in xy plane, then if I try to draw this line, contour line or circular line in xy plane, then in theta r plane, that is r equal to sine theta, surprisingly. Okay, if this is theta, then this is r. Okay, the circular line in xy plane, it will be resolved as r equal to sine theta. This is r equal to sine theta in theta r plane. Up. This is r equal to sine theta. Up. This is r equal to sine theta. If this is r equal to sine theta, means as theta is proceeding, radius is changing. This is the radius is vertical. When theta is 0, radius is 0. When theta is 90 degree, pi by 2, radius is maximum, that is 1. When theta is pi, the radius is 0 again. When theta is 3 pi by 2, radius is positive. Up. So it is sine theta, right? Okay. Okay, when it is 3 pi by 2, I'm sorry, 3 pi by 2, then sine theta is negative 1, minus 1. When it is 2 pi, it becomes 0 again. Okay, like this. It becomes 0 again. So this is the sinusoidal curve. Sine 270 degrees. Sine is perpendicular by the hypotenuse. Perpendicular is negative when 270 degrees. Okay, anyway. Now this is the, now can you find the area of a circle in xy plane? That is the only question written in the examination. Can you find area of a circle in xy plane? X square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Area of this circle without the formula that pi r square is the area of a circle. Can you find it? Now someone will now say, yeah, I can find it. Let's consider there is another variable called r, and r equal to a square root of x square plus y square. There is another variable called theta, and theta equal to tan inverse y by x. Now I have r theta plane where r equal to sine theta. Okay, now I have in r theta plane, I have a sinusoidal line. Whereas in xy plane, I have a sine x. Makes sense? Now if I have a sinusoidal line, then consider that I'm trying to find area between 0 to 2 pi, not 0 to 2 pi. What? Okay, let's draw r equal to sine theta in xy coordinate system. If this is x axis, this is y axis. If r is r square equal to x square plus y square, that is a circle. Okay, tan theta equal to tan inverse y by x means that is the angle. Means this is the red. If this is x and this is y, if this is a circle. Anyway, if this is a circle, if I take any point x comma y, then y is the height and x is the base. X square plus y square root means this is the radius. The hypotenuse is the radius. If this is y and this is x, y by x is the tan theta. Theta is tan inverse means this is the angle theta. Okay, if that is the case, y r equal to sine theta means when theta is 0, radius is 0. When theta is growing, radius is also growing. When theta is 90 degree means At this moment, there is no radius at all. When angle is theta, there is no radius at all. When theta is growing, radius is also growing. When theta is 90 degree, radius is maximum 1. When theta goes to 135 degree, radius starts shrinking again. When theta is 180 degree, radius is back to 0. It forms a circle like this. It forms a circle like this, where the end point of the circle is the origin. Okay, center is here, and this is the beginning. The radius is 0. As angle is growing, radius become 90. Angle is 90 degree, radius become maximum. Radius start decreasing and radius becomes 0. Okay, angle spans from 0 to 180 degree only, not to 360 degree. If I take theta or plane, then angle r equal to sine theta. Then the curve is like this. Hop, hop, hop. Then curve is sine theta curve is like this. This point is 180 degree and this point is 0 degree. This is the curve like this. Okay, then I have to find area of this. If I find area of this, then mapping to this area is the circle. This area is not a circular area. If I find this area, mapping to this on the xy plane is a circular area. But what is mapping to the circle in xy plane in theta or plane is a sinusoidal from 0 to pi only. This is the area of the concern now. Now let's chop this theta axis into n part. 0 to 180 degree into n part. Let's chop radius between 0 to 1 into m part. M part. Okay, if that is the case, then I have chopped it into n part and this is into m part. Consider this is any ith section. Then this is any jth section. I have so many rectangular region here. In theta or plane in the sine wave, I have so many rectangular region here because I chopped theta axis into n part and r axis into m part, m for monkey, mountain. Then I have rectangular region. Okay, top part will not be rectangular, that we will tackle. Right now I have consider this is the ith part and this is the jth part. It will form a rectangle here. If it forms a rectangle here, then consider the lower end. If there is a rectangle like this, then lower left corner is theta comma r. Then this is theta plus delta theta I because it's ith section. Theta comma r. This is I have taken a small rectangle where width is ith section, height is jth section. If bottom left corner is theta comma r, this width is delta theta I. This point is theta comma r. This point where r is constant and theta is moving. This point is theta plus delta theta I comma r. If theta comma r, then this point where theta is constant. This point is theta comma r plus delta r j, jth section. This is the area. This area, if I try to map in a circular region in xy plane, this is the theta or plane. This proof probably people would not find in the book. I have not taken from any of the book. If there is somewhere, then it would be luck only. But I don't think so. Anyway, now this is xy plane where this is x-axis and this is y-axis. This is how the circle is. If this is the case, then I am at any now the bottom left of the rectangular region is theta comma r. Means if I move theta, this is theta and this is r. Okay, this is r, any point. I am talking about this is x-axis, this is y-axis. Okay, this is circle is like this. Now if I take it as r, then this is at any angle theta because left point is theta comma r, theta and any r. This is the point theta comma r at angle theta and distance r, theta comma r, where r will go 0 to 1 and theta, this angle theta will go 0 to pi. That's it. Okay, in between I have taken as r and theta. This is the theta comma r. One is I'll proceed along the r, this is r, then this is r plus delta rj where theta is constant. Then another is I proceed in theta. where radius is constant. So this point is theta plus delta theta I. The movement of theta is delta theta I. This point is theta plus delta theta I comma r. This point is theta comma r. This moment is theta comma r plus delta rj. Now I have two vectors now. If someone is watching this very clearly, I have two vectors. What is the area? What is the area you're talking? This is the section, that is delta r. And this is the section. This point is theta comma r. If I move like an arc, circular arc, then this point is theta plus delta theta I comma r. This point is r plus delta r. Means this is the area. This is the circular area. Circular area that is corresponding to theta delta theta I delta rj in the theta r plane. This is the area in xy plane. What is this area? If I find this area, then this is the area of the ith jth section. There are m into n. If I take theta r plane and this is circle, if this is the, this is the sinusoidal wave, I have chopped into n into m part. There are n into m sub rectangles are there. At the corner rectangles are not there along the edges. But there are more or less, there are n into m rectangles are there. If I talk about the ith and jth section, it forms a rectangle whose lower left corner is I theta comma r, width is delta theta and height is delta r. Similarly, in xy plane, if I talk in a circular manner, then I have plus first the radius will move theta degree, and then I have r. Okay, this is theta comma r. If I move in delta theta, it will move like this in a arc manner. This line is the one point is theta comma r, another point is theta plus delta theta a comma r, keeping r constant. And keeping theta constant, another point is theta comma r plus delta r. This is the area. Now I can write summation I equal to 1 to n summation j equal to 1 to m area of the ith section. If I add all this area that is controlled through the theta, that is the main thing. This area in the xy plane, that is the circular area, this is controlled by the xy plane. If someone is watching minutely, there it is a rectangle and here is a circular arc. How to calculate this area? If I talk in area in the theta r plane, it is delta theta I into delta rj. Simple. Because both are vertical to each other, both lines. But here both lines are not vertical to each other. This is the radius vector and this is the arc vector. What is the area in between? I don't know. Okay, to calculate the area, I have to take cross product of this line and this line. If this is the line and this is the line, if I take cross product, I'll get this area. Okay, then why didn't you take cross product in the theta r plane? That is also cross product only. Delta theta I cross delta rj, they are 90 degree to each other. So cross product become simple multiplication and area is delta theta I into delta rj. Here it is, now what is cross product here? Cross product of this vector and this arc vector. If I take cross product of this arc vector, arc can be described as a vector, possible. If I take arc vector, that is theta is varying where r is constant, and take I this vector where r is varying, theta is constant. If I take cross product of these two, I'll get the area in between. What is this vector? What is this vector? If consider this point that is theta comma r is p, then this point is p2, then this point is p1. P1 cross p2 is the area. Okay, now I can rewrite as summation I equal to 1 to n, summation j equal to 1 to m, area of the ith section, that is P1 cross P2. What is P1? What is P1 vector and what is P2 vector? That I have to find. Okay, P1 vector cross P2 vector is the area. Okay, can I write now P1? Mind it, P1 vector is if I now I have to find P1 vector. P1 vector is an arc vector. This is an arc vector, not at the circumference. Anywhere it is an arc like this. One point is P, that is theta comma r, and another point is theta plus delta theta I comma r. This is P1 vector. If I take only end point P and P1 and connect it through a straight line, then it will be a straight line. Okay, it will be a straight line. And if I connect P and P2, it will again be a straight line. Okay, cross product of these two, then I'll end up in getting an area which will be area between a straight line and a straight line whatsoever. Okay, or I can describe P1 as a curved line vector. That is also possible, that we will see. Anyway, now we have P1 cross P2 vector. That is the area of the ISJS section. That area magnitude, and then I'll add it for I equal to 1 to n, j equal to 1 to m. I get the area of the circle. Make sense? Okay, let's proceed. P1 vector, P1 vector, P1 vector, I can write as delta P vector, P1 vector, P1 vector, P vector and P1 vector, P vector and P point P and P1. What is P and P1? Okay, that we will see. What point P and P1? That we will see. What is point P and P1? What is point P? P is r comma theta. If I take in x and y, then it point P can be x and y. This point P is r comma theta, but since it is in xy plane, I can say it is x comma y. If it is x comma y, then what it is? If it is x comma y, then this is g theta r comma s theta r. G theta r comma s theta r. Okay, x and y are function over theta and r. Theta and r are also function over x and y. That is true. If I say this point is theta comma r, corresponding to theta, this is not exactly theta comma r, corresponding to theta comma r, but I can rewrite as x and y. If it is x and y in Cartesian, because this is x-axis, then this point can be any x comma y. What is x? X is r cos theta. What is y? Y is r sin theta. Consider x equal to g x comma y, function over x, and x equal to g theta comma r, function over g theta comma r, y equal to h function theta comma r. That is h theta comma r is r sin theta. G theta comma r is r cos theta. This point is g theta comma r comma s theta comma r. If I take P1, then that is g theta plus delta theta comma r comma h theta plus delta theta comma r. If I take point P2, then it is g theta comma r plus delta r comma s theta comma r plus delta r. Cross product of these two vectors will give this area. Straight line. If I take now, what is this vector? P and P1 vector. If I take P1, what is the area? P1 vector cross product P2 vector. It will result in another vector. Take the magnitude, that is the area of the ISF, but area will be one side is a straight line, another side is also a straight line. That area it will give, not the curved line area it will give, but we'll go through. Okay, if that is the case, then what is this vector? This vector is G. This vector is P1 vector. P1 vector. Okay, can I rewrite as P1 vector cross P2 vector divided by theta, delta theta I, delta rj into delta theta I, delta rj. Possible, right? Anything I can divide by an amount, I can multiply by the same amount. Okay, what is the area of ISJS section? It is delta. Area of the ISJS section is P1 vector cross P2 vector. Now I am dividing it by delta theta I, delta rj. Then multiplying by delta theta I, delta rj. Delta theta I, delta rj, I can take out of the magnitude what we are talking about. Now it becomes, since it is multiplication, I can take two sides. P1 vector by delta theta I cross product P2 vector by delta theta, delta rj. I can write like this. What is P1 vector? What is P1 vector? P1 vector, if I say, it is subtraction of P1 and P. That is, now it is G theta plus delta theta comma r minus g theta comma r. Okay, comma, which means this is the ith part of the vector, or I, I plus h theta plus delta theta comma r minus h theta comma r j divided by delta theta I. By the first principle of derivative, if it is g theta plus delta theta I comma r minus g theta comma r I plus h theta plus delta theta I comma r minus h theta comma r j divided by delta theta. This is exactly a first, first principle of differentiation. dy by dx is same as fx plus delta x minus fx by delta x. Same is here also. G theta plus delta theta comma r minus g theta comma r by delta theta is dg by d theta. Now I have this I vector plus h, same thing, j vector by delta theta. It is same as d dgh by d theta. D of differentiation of g theta comma r comma h theta comma r by d theta, or d, what is d theta comma r comma h theta comma r, that is x comma y, x comma y. What is xi plus yj? Okay, that is the position vector of point here. This is this point we were calling as representation of theta comma r from that theta comma r, that is x comma y. This point is not theta comma r, actually this point is g theta comma r comma s theta comma r, because I am representing in x and y. Now what we are talking is this area, what we were talking, this area is cross product of p1 vector cross product p2 vector. P1 vector cross P2 vector, I divided it by delta theta I into delta Rj, then I multiplied the same factor. If I see P1 vector, it lines up in G theta plus delta theta I comma R minus G theta comma R I unit vector, because it's a vector. At the end it is a vector, plus S theta plus delta theta comma R minus S theta comma R J divided by delta theta. It becomes D g theta comma r I plus h theta comma r j by d theta, that is d of xi plus yj by d theta. Okay, it is same. Now if I see right hand side cross product, that will become d xi plus yj by dr in similar fashion. Okay, that will be g theta comma r plus delta r minus g theta comma r I vector plus h theta comma r plus delta r minus h theta comma r j vector by dr. Okay, it will become d dxi plus yj by d theta cross dxi plus yj by dr, magnitude delta theta I delta rj. This I can term now. What is dxi plus yj by d theta? Xi plus yj I can rewrite in the theta and r as per the polar coordinate system, where x is r. Anyway, x is r cos theta. We have taken like that. X is r cos theta, or it is d of g theta ri plus h theta rj. The way we started, g theta r is r cos theta, and h theta r is r sin theta, that is y. D of r cos theta I plus r sin theta j by d theta. This will become differentiation only when if I take delta theta I tends to 0, then only it is possible. Means if I chop in our theta r plane, the r equal to sine theta, if I chop into n part where n tends to infinity, if I chop into m part, m tends to infinity, so that delta theta and delta r tends to 0, then only it will become differential calculus. Fx plus delta x minus fx by delta x will become dfx by dx only when delta x tends to 0. It has another advantage. If delta theta tends to 0, then we had taken this point as theta comma r, that I transform into x comma y. If I move delta theta, then this point is theta plus delta theta comma r. This is a curved line that I am representing through pp1. If delta theta I tends to 0, then this curved line will be tends to straight line only. If it is tends to 0, more or less we are getting exact the area of the one section. So what is exact area of one section? D of r cos theta I plus r sin theta j by d theta cross d of r cos theta I plus r sin theta j by dr. Its magnitude delta r or delta theta I delta rj, where delta theta I tends to 0, delta r tends to 0. This I can rewrite as summation I equal to 1 to n tends to infinity, summation j equal to 1 to m tends to infinity, function over theta and r, because d of r cos theta I plus r sin theta j by d theta will resolve in r and theta only. dr of sin r cos theta I plus r sin theta j by dr will resolve in function over theta and r only. Function over theta r delta r, or I can rewrite as function over theta r d delta theta r. Means if I have axis like delta theta and this is function over theta and r, I chop it into m into n part. If I take any section, then function over theta r is the vertical and this delta theta r is the horizontal. This is the area of one subsection. If I add for all ij, it will give full-fledged integration that can be rewritten as integral sign, integral sign, integral sign where theta r is from begin, theta r is up to end. Function over theta d theta r or d theta dr. What is function over theta? Someone has to compute this. D of r cos theta I plus d plus r sin theta j by d theta cross. This is also called Jacobian. D of r cos theta I plus r sin theta j by dr. If someone calculates, it will become r only. R and magnitude r d theta dr. What about this limit? That is the question now. What is the limit? Okay, what do you want? I want limit of theta and r. If I want limit of theta and r, see theta and r. Yeah, I know theta and r. This is theta axis and this is r axis. What is the limit? This is the sinusoidal line. Limit is theta is going 0 to 2, 0 to pi. Yeah, thank you very much. R is going 0 to 1, that is false. R is not going 0 to 1. R is variable. If theta is, if there is a sinusoidal line on the theta axis, this is sinusoidal line where r is varying and r equal to sine theta. This is the sinusoidal line. If this is a sinusoidal line, if theta is moving, then this r that is vertical is also keep on changing. It is not constant. If I say what you want to integrate, I want to integrate along this sinusoidal area. Integration of theta and r from begin to end over means this is area. If there are two things in integration, theta and r, then we are integrating over area. If it is only theta, then we are integrating over a line. If it is theta and r, we are integrating over an area. What is area? What I'll say beyond this, that is not written in the book. This much it will be written in the book. We are integrating over an area. What is area? Anyway, right now the area is sinusoidal. If it is the area, then theta is going 0 to pi and radius is moving like this, where radius is a function over theta. It is not a straight line. If it is a straight line, then radius I can say 0 to 1. Radius is changing. This is the area underneath which we have to integrate. Then it is theta is 0 to pi, radius is 0 to sine theta because radius is changing. Then r d theta. If someone compute that, he will get the area. Let's focus on the integration area. This is what not written in any of the book. Okay, consider. Okay, what is function over theta d theta dr and integrating it? Consider this is theta r plane. What is theta r plane? Consider this, from my side I will say, this is theta and this is r. This is theta and this is r, theta r plane. If it is then if you make a theta r plane, function over theta means height, that is z axis. This is function over theta. It creates a volume. Unknowingly, knowingly, we are trying to calculate a volume where theta r from begin to theta r to end. Function over theta r d theta dr. It is we are calculating a volume. What is volume? Volume means height by width area. If there is a base area multiplied by the height, if base area is a rectangle, then rectangle area into the height if I multiply, I get the cuboid volume. So if I try to find the cuboid volume, if I have function over theta and r, I'll multiply this height with the bottom area. Okay, right now I have bottom is sinusoidal. If this is theta and this is r, then there is a sine curve like this. There is a sine curve like this. Oh, from my side, this is theta and this is r. There is a sinusoidal line like this. This is the reason. Theta and r must be inside this region only, not beyond it. This is not theta and r. Theta, if this is theta and this is r, then this is the sinusoidal region. This is sinusoidal wave. In this region only I have to take theta and r. Whatever function over theta, what is written? Limit theta and r from begin to end. Function over theta d theta dr. Function over theta is the vertical. And this is the theta r plane where this is sinusoidal line. This is the set of theta r point. Infinite points are there, that is theta and r. But it must be within this line only. That is the concern. Okay. And then this is the vertical. F theta r. We are calculating a volume where base is confined in this area. So if base is confined in this area, our limit must be in this area. If I say theta is 0 to pi, then r cannot I say 0 to 1. If I say 1, 0 to 1, it will form a rectangular region. This is what I don't want. I want sinusoidal region only. In that sense, if theta is 0 to pi, then r is varying. R is varying everywhere. R is 0 to sine theta. If theta is 0, then r is 0. See? If theta is pi by 2, then r is full. If theta is pi, then r is 0. So integration will be theta 0 to pi, r is 0 to sine theta, the curve line. Because we have to calculate this is the area. But if you see any book, okay, let's integrate over the rectangle sinusoidal region. What is sinusoidal region? This is what it is. Function over theta dr. Someone can calculate and he will get the area of the circle. These are explanation are way away it is mentioned in any of the book. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. Please mind supporting us. +91 is the India country code, 9483160610 is the telephone.